Okay, we're going to work problem number 2 from the homework, but you see it has an A, a B, and a C. So we're working B to A, which is the superposition principle when we're dealing with electric forces and we have more than one charge. So after we looked at the notes, step number 1 is to draw the picture. So it says 4 charged particles are placed so that each particle is in the corner of a square. So what I'll do first is, just to conceptualize this, here's my square. So the sides of the square are 15 centimeters, so I know each side is 15 centimeters. The charge in the upper left corner is plus 3 microcoulombs. So this is going to be a positive charge, and this is 3 microcoulombs. And in my given, I would like to write all that information to look at. So the distance of the square is 15 centimeters, which I'm going to convert to 0.15 meters. And remember, it's a square, so it's the same all the sides. Then it says that the charge at the upper right hand corner is minus 6. So this one is negative, and this is negative 6 microcoulombs. Now when I put these charges, so this I'm going to call Q1, I'm going to call this Q2. If I don't label them, I'll probably get confused. That'll really make it easier. So now I'm going to say Q1 is plus 3 microcoulombs. Now remember, micro is a prefix that means 10 to the negative 6. So I'm just going to rewrite this as positive 3 times 10 to the negative 6 coulombs. I'm going to write Q2 is negative 6 microcoulombs, which would be negative 6 times 10 to the negative 6 coulombs. The charge at the lower left is minus 2.4. So this one is negative 2.4 microcoulombs, and I'm going to call this one Q3. And the charge in the lower right is negative 9 microcoulombs. So this one is also negative. This one I'm going to call Q4, and this is negative 9 microcoulombs. And now I'm going to put this in my given. All right. So I have my picture. This was step number 1. I wrote my given. Now, the question says, calculate what is the net electric force. I want to find the net electric force on the 3 microcoulomb charge. So first of all, I have to say to myself, which one is the 3 microcoulomb charge? That's this one. So I want to find the net force on that. Now what I'm going to be using over and over and over again is I'm going to be using Coulomb's law. So F is equal to K Q1 Q2 over R squared. That's what we did for practice A. Now with this orientation, there's not just one force. I'm going to have several different forces. So I'm just going to do this to the side, because what happens is I have to find the force between these two. I have to find the force between these two, and then I have to find the force between these two. Okay? Now, the direction of the force makes a difference as well. Okay? So if I drew it to, I'm just going to draw it to the side to conceptualize for you. This represents my 3 microcoulomb charge. So now I want to find the force between this one and 3. So this is going to be F13. This is going to be F12. and this is going to be F14. After I find this, this, and this, I'm then going to find the horizontal and vertical components of each, and I'm going to add up all my Fx's, all my Fy's, then find my final force, and then find the angle. So we did this before when we did forces earlier in the year. It's just a lot of steps. All right, so step number 1, I'm going to find first, I'm going to move this up, I'm going to find F12. So that's going to be K Q1 Q2 over R12 squared. So R12 is the difference, the distance between Q1 and Q2. So this is going to be 9 times 10 to the 9 Newton meter squared per coulomb squared, times Q1 is 3 times 10 to the negative 6 coulombs, times negative 6 times 10 to the negative 6 coulombs, all over 0.15 meters squared. Now when I do all this in my calculator, F12 comes out to be negative 7.2 newtons. Now first of all, before I go on, I kind of want to check my work. It is first of all as far as the sign. So Q1 is positive and Q2 is negative, so a positive times a negative should give me a negative answer. And with unlike charges, I should have a negative answer, because that means that that is a force of attraction, because unlike charges attract one another. Now I'm going to find F13. So F13 is going to be K Q1 Q3 over R13 squared. So that's going to be 9 times 10 to the 9 Newton meter squared per coulomb squared, times 3 times 10 to the negative 6 times negative 2.4 times 10 to the negative 6 coulombs, divided by, and the distance between those two charges is 0.15 meters squared. So when I do all that on my calculator, F13 comes out to be negative 2.9 newtons. Now I'm going to do this one more time because I need to find F14. Now, before I go on and I find F14, I want you to come up here and look at the picture. The distance between Q1 and Q4 is this distance here. Now, is that distance here, this is going to be R14, is that distance there 0.15 meters? No. Remember, this is 0.15. This is 0.15. So what I have here is I have an isosceles triangle. Can I find this distance? Yes. So before I go on, what I'm going to do is I'm going to try and find that distance real quick. And I'm going to say that, and if you want, you can add that to your given up here. I can say R12 is 0.15. R13 was 0.15. And now R14, what I'll do is I'll just find it over here to the side. So this is 0.15, 0.15, so R14 is going to be the hypotenuse, so I would use the Pythagorean theorem and say R14 is the square root of 0.15 meters squared plus 0.15 meters squared. So R14 comes out to be 0.21. The math isn't difficult on this, it's just tedious because we have 4 charges. Okay. So after I get R14, what I'm going to do is, again, I use the Pythagorean theorem, it's an isosceles triangle. I'm going to go back and find F14. So F14 is equal to K Q1 Q4 over R14 squared. And now I have R14. So it's going to be 9 times 10 to the 9 Newton meter squared per Coulomb squared times 3.0 times 10 to the negative 6 coulombs times negative 9 times 10 to the negative 6 coulombs, all divided by 0.21 meters squared. So when I do all that on my calculator, F14 comes out to be negative 5.5 newtons. All right, I'm going to change the paper in a second. Okay. So at this point, I have these forces, but you notice here the forces are all going in different angles like this. Okay? This one's all horizontal, this one's all vertical, and this one is going at an angle. So what I'm going to do is I'm going to find the horizontal and vertical components of each one of those and put them in a table. Because in the beginning of the year, we saw that when you have different forces, and I put them in a table, it makes it a lot easier to do this whole process. All right, so now I'm going to make a table. Makes it so much easier. And I'm going to have force. I'm going to have the X component, and I'm going to have the Y component. And my forces are F12, F13, and F14. Why am I doing the table? I'm doing the table because at the end, I'm going to have Fx, which is the total F, and I'm going to have Fy. So let's start off with F12. If you remember, and I'll just redraw this on this page so we can look at it real quick. This was the charge. This was F12. This was F13. This is already on your paper. You don't have to redraw this. I'm just showing you so I don't have to flip back and forth between the two pages. So F12 looks like this. It's all horizontal. So because it's all horizontal, that's all an X component. Because remember, we're using our standard Cartesian sign convention that up and to the right is positive. So this is going to be plus 7.2 newtons. And the Y component is going to be 0. So that's super easy. Then I'm going to jump ahead to F13. See how F13 goes down like that? So that means it's only a Y component. Now, according to our sign convention, down is what? Negative. So this is going to be negative 2.9 newtons, and this is going to be 0 newtons. Now, because this is F14, because this was an isosceles triangle, what is this angle here? It's 45 degrees. So now, let me just draw it to the side. This is F14. We know the magnitude of that force, but now I want to find the horizontal, F14x, and F14y. I want to find the horizontal and vertical components of that. Now remember that whenever we have a vector, the components from where I start to where when I end up, I want to find the components. So first I'm going to go horizontal from the head of this vector. I'm going to do the tail of the other because these have to always be perpendicular to one another. So F14x is going to be 5.5 cosine of 45. So F14x equals 3.9 newtons. And we see because it's going to the right, we're going to call that positive. F14y is going to be 5.5 sine of 45. This is all stuff we've done before. We're just putting it all together in this big problem for superposition. So when I do this, I'm going to get the same answer. I'm going to get 3.9 newtons. But when you look at your picture, this is going what? down. And according to my sign convention, down is going to be negative. Now, what am I going to do? The first thing I'm going to do is I'm going to add up my x's. So 7.2 plus 3.9, that comes out to be 11.2 newtons, and that's positive. Then I'm going to add these up, and this comes out to be negative 6.8 newtons. So this is my Fx and Fy. We did this before when we had 3 or more forces. Okay, and the table makes it a lot easier. So now that I have my Fx and my Fy, I just want to find my plain old F. So, first I'm going to draw Fx. So this is my starting point. Fx is positive, so here it is positive. So, whoops. This is Fx, and this is 11.2 newtons. From the head of this vector, I'm going to do the tail of the other. Now, because Fy is negative, I'm going to make it go down. So Fy is equal to 6.8, and I don't have to write the negative again. The negative I made when I made it go down like that. How do I find my resultant? From the head of this vector to like this. So this is just plain old F. This is F total. Now, I have a right triangle. Again, this is where I started. So this is always going to be my tail. This is where I ended up. This is always going to be my head. And I see that this is a right triangle, so I'm going to use the Pythagorean theorem. So F is going to be the square root of Fx squared plus Fy squared. So F is going to be the square root of 11.1 squared. And if you wanted to put the negative, it doesn't matter because when I square it, it's going to disappear. So F is going to be 13 newtons. And you might think, whew, that's a lot of work, but we're not done. Because we know that all vectors have both magnitude and direction. So we have to find the direction, which means I'm always going to measure the direction. I'm going to measure the angle from the tail of the resultant. Nothing changed. Remember, a force is a force. So we're going to go through our same exact steps. All right, so because I want to find this angle, I have opposite and I have adjacent. So now I know that I'm going to go back and I'm going to use tangent. So tan of theta is opposite over adjacent, which is 6.8 over 11.1, and the newtons cancel. So now remember, this is where some of you mess up on your calculator. Okay? So, it's too dark in here. So what we're going to do on our calculator is we're going to press 6.8 divided by 11.1 equals. But that is the tan of the angle. Remember, I don't want the tan of the angle, I want the angle. So then I press second tan, and it gives me the angle there. So theta, it comes out to be, it says 31.49, so I'm just going to round it to 32 degrees. So my final answer, and this is just for part A, I know, my final answer is F total, Dylan, F total is equal to 13 newtons at 32 degrees below the positive x axis. Because that's our frame of reference. This is the positive x-axis, and I'm measuring that angle below it. Okay? And that's our final answer, okay, for this problem. So it was a lot of steps. The math wasn't difficult. You just have to do it step by step by step.